Okay, decibel, bell, and logs. Now the decibel is the measure of sound. It's a logarithmic unit, and as you probably know, the further you move away from a speaker, if you double your distance from the speaker, the volume doesn't halve. There's a logarithmic change in the volume. Now we've discovered that if I want to calculate my gain, let's say the voltage gain, we look at the output voltage divided by my input voltage. But this is just the gain of the electrical signals. When it comes to the gain of the audio, we need to incorporate that decibel gain, or the consistency of the fact that the further I move from the speaker, the volume will decrease. Now decibel is the measure of volume, and we can calculate the power gain in decibel as 10 log base 10 with power out divided by power in. Now when there is a 3 decibel change, it means that my power has changed by a factor of 2. In other words, if I double my output power, then I will get a +3 change on my decibel. If I half my output power, then I get a -3 change on -3 decibel change on my power gain. The RC coupled amplifier. Okay, in this circuit, although we're going to double it, RC1, or the collector resistor, serves to cause a voltage divider for the output. The transistor is in charge of the amplification, and the gain will be determined, or the Q point will be determined by the values of those two resistors. This combination is there to serve as a thermal runaway protection. That thermal runaway protection is obtained whereby this resistor causes DC resistance, and this capacitor will then serve for AC resistance. Now this capacitor over there will serve as my coupling capacitor between the first stage and the second stage. There again, I just repeat whatever happened over there. Two base resistors, collector resistor, emitter resistor, capacitors, and then there goes to my output. There goes to my input. Now what we see over here, when we supply power, this resistor along with this resistor forms a voltage divider, which will put this transistor somewhere, the Q point somewhere on its load line. The same applies over on this second transistor. Now as my input voltage there increases, let's say I've got a positive signal there, this capacitor charges, that changes the voltage on my biasing, which in turn will turn my transistor more on. In other words, the area of operation is going to move upwards. That is going to cause my output voltage, the voltage on this capacitor that feeds to that transistor, to basically decrease. Because that voltage decreases, I can effectively say that I am applying a decreasing voltage, or a negative voltage, on this transistor. Because of that negative voltage on this transistor, it turns more on, which moves its point of operation in that direction. So its voltage is increasing, and as a result my output voltage there will increase according to the gain. When I decrease this voltage, my area of operation will move in that direction, which means VCE is going to increase. Because that increases, my output voltage there is going to increase, and because it increases over there, this transistor is going to turn more on, which means it's going to have a smaller voltage connected across it. So we can see we put in a sine wave. The output for the first stage is a reverse sine wave, and then the reverse sine wave gets amplified by the second amplifier circuit, which puts it back into the positive sine wave. Now the frequency response for this circuit in other words, how well does it fare at a wide range of frequencies, looks somewhat like that. You've got low frequencies on this side, you've got high frequencies on this side, and then over here is my half power level. That's -3 decibels. That point there is 0 decibels. That's the maximum power that we're going to get. So anything below that level we're not going to look at. So that's my low frequencies, and then there I will have my high frequencies with my middle frequencies there in the middle. At very high frequencies, in other words at that point there, these capacitors will develop a very low reactance, and as a result there's a very low voltage being fed through from the one stage to the next. Okay, I've mentioned the -3 decibel level is my half power level, and at that level we will have 0.7 or 70.7% of full power. Anything below that we consider losses. And when it comes to calculating the gain of my RC amplifier, if I want to calculate current gain, then I say 20 log base 10 output current over input current. I can use the same formula to calculate my voltage gain, 20 log output voltage divided by input voltage, and then to calculate the power we can use that formula again.